on using anonymizers and still getting fucked. Have fun.
So, thanks for coming to this talk. This is Lexi. I am Dominik. Lexi is working at IDEF. I am working at University of Regensburg. And we're going to talk about 4 different topics related to profiling of web users in presence of anonymization services. So first part is Lexi's part.
There's one major subline on the whole talk, and that is provided that you are using some kind of IP layer anonymization service like a single hop web proxy, Tor, whatever, choose it, you are not just safe automatically. And we'll show several examples in this talk that still can do some harm to you. The first part is filtering of JavaScript in web-based proxies. So web-based proxies are something like PHP scripts proxying HTTP requests. You have seen those most likely. And we have taken a look at 2 of the more popular implementations. Unfortunately, both of them are kind of dead pigs, so hacking them is really not so much fun. Still, they are out there and they are widely used. So just in case you come across one of those, be very cautious. If you look at the code, it feels a little bit like rocky training, so just beating on a dead pile of meat. The first thing is actually, well, why don't you want to have JavaScript in your browser? Because JavaScript is a Turing-complete language. You can do a lot of stuff with it, and especially you can profile users in a lot of ways. Like, I'll skip those details, but I just give them orally because you already know it. You can grab the screen size of the user and profile him. You can get the time zone of the user. You can get the clock drift from the user, like if his clock is permanently 5 minutes late, you can use that to identify the user. And there are many more examples. So basically you don't want to have JavaScript running in case you want to be anonymous. Now, PH proxy does use regular expressions to filter out JavaScript. The problem is that HTML is a language that is way more capable than regular expressions. If you have ever visited a second-year computer science class, then you probably know that regular expressions are just regular automata. But in order to pass HTML, you need something like stack machines. So this goes wrong in just another way, and I will not go into that in many more detail. I'll just show you that first what PH proxy does is it removes all the script tags, and after he is finished, he removes the no script tags. Why he does it, I don't know, because if you just use this way, then PH proxy will, well, actually it will just remove only the no script part, and then you got all the no script, the JavaScript through the web-based proxy. And then you can again use all this JavaScript to profile the user. Okay. So the use case for this one is a user has no script enabled, but it just has enabled JavaScript from the original web page, but not from any other web page. So what you can still do in JavaScript is you can just load a CSS from another server, and usually the loading of CSS is not filtered in any kind of web-based proxy. So you can use this one also to just identify the real IP of the user. And finally, some proxies do filter JavaScript applets, Java applets or Flash applets, but they just filter here the original path up there. What the what the coders of those proxies did not knew, that if you put the path a second time down here in the param tags, this one gets completely ignored. So while they filter that one, this one is actually getting used. So it makes no sense to filter that one. So that was the first part.
Thanks, Lexi. And the second part is on identifying users based upon their web profile. So all of you are aware of the problem web profiling may cause to users' privacy. What I am talking about is if attackers are able to observe a user's web requests over a long time, they may learn the user's interests and even maybe their identity. Remember the AOL search log thing when AOL released search logs when some of the users contained in these anonymized log files could be de-anonymized solely based on their search keywords. Now, we're considering specific attackers in this talk only, and the attackers we are considering are either anonymizing proxies, like web proxies or CGI proxies. We are also considering third-party DNS servers, like the popular Google public DNS, which is pretty fast and says it's secure, and OpenDNS. And we are somewhat also considering anonymizers like Tor, but only very briefly. And the overall question is whether we can whether those adversaries can track your activities if you're using them. So if you're using anonymizer.com daily, can anonymizer.com track you over several days? That's the central question here. Obviously, this is rather trivial if you're always using the same static IP address. If you're always using Anonymizer from the same address, Anonymizer just has to basically union all your web requests and build a big, large, fat profile out of them. And until now, most people would think that it's rather difficult if you're not using the same IP address every time. So if your identifier changes frequently. And now you would say, fortunately, I'm using a DSL provider who assigns me a new IP address every day, and fortunately, Tor switches circuits every 10 minutes. But what would be if we could actually link multiple sessions and basically tie them together, match them together, solely based on your surfing profile? Then we probably would get into problems here, right? So let's assume this scenario. We started out assuming that user behavior as it is reflected by the visited destination host names, so the sites you're basically going to. And the situation is like depicted in the graph here on the left side. You got two users, user 1 and 2, from two distinct IP addresses, and those two users are visiting different hosts. They are basically surfing to different hosts. At a later time, you're observing two other IP addresses, IP 3 and 4, and the attacker questions now, is user 1 session 3 or is user 2 session 3, or is user 1 session 4 or user 2 session 4, or is it someone else, someone totally different? Fortunately, we don't have to do this manually, but we can use data mining techniques here. And using data mining techniques allows us to treat the session linkage problem as a classification problem, like a standard machine learning task. And what we're doing, we're feeding a classifier the earlier sessions, like session 1 and 2, training it with it, and then we're asking the classifier what it would predict session 3 is the matching user's profile. And then the classifier might hopefully say that session 3 looks very similar to session 2, and therefore both of them belong to user 2. The question is, which classifier should we take here? And this is a problem of its own, obviously, for those who are familiar with machine learning at least. And we observed that the total host access frequencies, so the number a host name is accessed by a large population of users, resemble closely the word access or the word frequencies in natural language. So on the left side, you see the distribution of words in the Bible. On the right side, you see the distribution of hosts if you have a large user base, like here on CCC. And those are obviously similar. And that's why we started out to tackle the problem with the same techniques as are applied in the text mining domain. In the text mining domain, we are talking about instances, about documents. And the document consists of terms, of words. And in our setting, the words are actually host names. So what we can do is we can use the instances, or we can construct instances by just adding the host names that are visited in a user session on a given day. And we don't have to do it ourselves, but we can use standard text mining tools like the Weka package, which is a Java machine learning package. And we just use all the tools Weka contains for text mining, like the string-to-word vector filter. The filter reduces weights and tunes the vectors in a way so that bad things are not happening and certain characteristics are removed. And then we can use the so-called multinomial naive Bayes classifier in order to classify texts or hosts or sessions. And fortunately, I'm not going to talk about the intricacies of this formula here, but I just tell you that the basic idea is that the more often you're observing a host in a session by a given user, the more likely it is a session that belongs to the user if the user has accessed this host in the past, which makes total sense. So if you're going daily to /.com and the attacker observes you going to /.com, he argues, well, that's probably the same user. Obviously, /. is a very bad example. In order to evaluate this hypothesis, whether this would work, we carried out a small study with 28 volunteers who volunteered their traffic, 57 days in total, to us. And obviously, it's not very easy to find such volunteers, especially if they're volunteering their traffic to interested researchers. So we had to think about privacy here. And what we did is we recorded all the traffic at their site on their local machine with a proxy, Privoxy actually, and obfuscated all the host names in the log file with a salted hash function, so that we ourselves would not be able to find out which host names they were looking at. We were only seeing hash values actually. And all participants uploaded their log files via an anonymizer, so that we really don't know who uploaded what. The scenario is basically like this. The attacker wants to track on day T some specific user. He trains a classifier with all users that are present on that day. On the day T+1, next day, following day, he is confronted with different IP addresses, different sessions, and now he asks the classifier to predict what the mapping between sessions in day T and sessions in day T+1 is. And we, as researchers, we can actually evaluate this because we know the true mapping, we know the true identity, at least we know the true pseudonyms of the users, although we don't know their identities. And repeat for all days and sessions. The results are rather intimidating. All 28 users had some characteristics, and we could actually link 77% of consecutive sessions. So from one day to another, if you were using the same service, in 77% of times, those two sessions would have been linked. There was one especially poor guy in the study. We could link 39 out of 57 days, using only host names. Now, while this is certainly interesting and maybe even a problem, we wanted to know whether what the actual characteristics of this problem are. So what we did is we looked at different session times. So far, I only looked at day, meaning 24-hour session times, and you see this is the peak with 1,440 minutes in this graph. But what's also interesting is that when you're doing really short session times, like 10 minutes or 5 minutes, remember Tor's 10-minute circuit switch time here, you see that the accuracy actually goes up again, which totally makes sense, because when you're surfing on /. You might do that for 5 minutes, for 10 minutes, and if you happen to be the only guy doing that, then your sessions, your consecutive sessions, can be linked easily. Now, for consecutive sessions, this is probably not so difficult, but what happens if the offset between training